Okay, I got it. Do you see? Okay, it's GeoGebra also, but it's another
Yeah, I
folder.
see.
It's a folder in graphic in 3 dimensions. Don't be scared because you don't need to know 3 dimension. This is a topic for the calculus 3. But to understand the conic section, I need to see something, no? This is the figure that you can see now in 3D, 3 dimension, is a double cone. Do you see the double cone? Double cone. Entonces,
Yes,
this
sir.
double cone, so we have 3 axes. The red one is X, the green one is Y, and the blue is the Z axis, 3D, 3 dimension. So I want to intersecting this double cone by one plane. The plane is this, boom, blue plane. And the curve is formed by the intersecting the double cone and the plane is something like that. You see in pink color. However, in order to see much better, I want to delete the plane. I want to delete the double cone. Boom. And you can see the curve now. Okay? This curve is called ellipse. Ellipse look like similar to the circle, but no, exactly because the circle is perfect symmetry. So any point is equidistant from the center, but in the ellipse, no, because ellipse is a little bit compressed. In what direction? I don't know, see in the horizontal direction or in vertical direction. We study in detail today now. Okay, this is the ellipse. This is the first conic section that we study today. Okay, nice. Everyone saw that or no? We come back again to the double cone. Double
Yes,
cone.
sir. We see it.
Okay, perfect. Now I want to intersecting this double cone again using another plane. In this case, the orange plane. Look at that, orange plane. What is the only difference? Well, the only difference is the angle of the inclination of the plane. Okay, and the intersection is a curve, que is exactly the curve that we want to study, no? It's a blue. And to see much better, I delete the plane, I delete the double cone. You see that curve, que es obvio que es the famous parabola. This is a parabola. What's going on? It's a parabola. Look, parabola. Parabola is different to ellipse because ellipse is a closed curve, like a circle, no? Pero a little bit compressed in one direction. Parabola no. Parabola is open curve. We have a vertex, que is when the point is turning, so the parabola change the direction, no? Turning point. But it's infinity in both directions. Open both arms in both directions. It's the parabola. And we study in detail the parabola, but in more detail than called algebra. We study the different parabola that we have, the most important parameter, blah, 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 blah. Maybe not today. Maybe next time, next week. Okay, now where's the last one? So the last one is, again, we come back to the double cone. The double cone is intersecting with the another plane. Wow, in this case, I don't know exactly what color. This is gray, no? Gray. It's a little bit like a blue-gray. I don't know. Entonces now the curve is intersecting, formed by intersecting double cone and this plane. Look like that. Boom, 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 boom. In green color, pero it's no confusing. It's confusing. Let me delete the double cone. Let me delete the plane, and you can see this. This is a hyperbola. It's the name of the hyperbola or hyperbola. The most important is that hyperbola contains 2 branches. Okay, 2 branches. So there are different kind of course the hyperbola. One branch of the hyperbola open up, another branch of the hyperbola open down. Or we have another possibility is the one branch of the hyperbola open to the right and another open to the left. Let's see how you identification using the equation. Okay, But the most important I want to illustrate que this conic section, que es ellipse, parabola, and hyperbola, conform to the double cone. That is the reason it's called a conic section, because it's a cross section of the double cone. And we study in pre-calculus, no elementary, we study complicated, right? But in calculus 2, you unificate the equation for this conic section in only one. It's unbelievable. In pre-calculus, we study using the classical rectangular coordinate system, no? And then to say you have one equation for the ellipse, one equation for the conic, for the parabola, one equation for the hyperbola. However, in calculus 2, we're using another point of view, and you unificate this equation. And this is expecting because it belongs to the same family. Pero es to see, you need to change completely the coordinate, no XY. No, it's another coordinate. You in calculus 2 you see. Okay, so, we have a family. The family is ellipse. Ellipse. The second parabola. And the third one, hyperbola. Hyperbola. Ellipse is a closed. So we have maybe like that or like that. I call horizontal ellipse. This is horizontal. And this is vertical ellipse. This is my name. And the book never call like that. But I for my student, I call, this is horizontal, this is vertical. How do you know? And the parabola is the same. The parabola, you have parabola that open in that direction. So open up or open down, depending. It's the same family. This is vertical. And another parabola can open to the right or to the left. This is horizontal parabola. And hyperbola contain two branches, like that. This is horizontal hyperbola, and this is vertical hyperbola. Vertical hyperbola. But today we study only ellipse, because we need to study in detail and doing several examples for the ellipse. Ellipse, let me show you the most important thing you need to know about the ellipse. Okay, number one is the equation. Well, we have one possibility of the equation is x squared over a squared plus y squared over b squared equal. This is like a classical, standard is the name, a standard form of the equation of the ellipse. We can do some modification. For example, in this, the center is located at 0,0. And the center is that point. So suppose that my ellipse is like that. It's 0,0. When the center is not 0,0, it's another hypothetical point. It normally is similar to the Euclid algebra, h, k. Remember, h is the letter associated with the x component, and k is associated with the y, no? Is the point of this. So when you have some translation like that, and the center of the ellipse is another point is not 0,0, this is the equation change a little bit like that. X minus h squared, a squared plus y minus k squared over b squared equal 1. Okay, this is when the center is 0,0, center. And when the center is not 0,0, it's h, okay. Don't worry, guys. I bring today a lot of examples. We are doing using decimals. But I try to discussing quickly, theoretical part. So maybe the question is, well, who is A, who is B? It's a number. It's basically a number, but A is always, okay, this is my ellipse. Let me try to do a roughly sketch for the ellipse. A is always bigger than B. So suppose, hypothetically, this number is 16, this number is 9. Entonces, A is a square root, this number, represent well, we have two axes. Let me use in two colors. This axis is called major axis because it's the big one, no? Major axis. And this axis is the minor axis. Minor and major. That's the technical name. This is the total axis, and the half of this is semi minor or semi major. Okay, so what is that? Semi major axis is semi major is this segment. It's a half. And semi minor is this segment. It's also half. Okay? And this segment is a semi is A. And this segment is B. Entonces, suppose hypothetically que one ellipse, que the question is x squared over 16 plus y squared over 9 equal. You made the identification that a squared is 16 and b squared is 9. Therefore, a alone is 4 because it's a square root of 16 and a is 3 and b, sorry, is 3. Entonces, my ellipse look like that. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. Something like that. Because the major axis, K4, this point is 4,0 in this example, is associated, so the big number, K16, so 16 is bigger than 9, no? Is associated with the x. That means that our ellipse is horizontal. So the major axis lie on the x-axis, or at least parallel to the x-axis. And the minor axis lie parallel to the y-axis. Bueno, okay, professor. Entonces, I suppose que I change the number, okay, no problema. Suppose x squared over 9 plus y squared over 16. 1. Entonces, ¿es the same ellipse? No, because in this case, a squared again is 16, b again is squared is 9, a and b is the same, a is 4, b is 3, but the orientation is different because the big number is associated with the y. Entonces, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. And my ellipses look like that. Well, like that, no? Es vertical. And this is horizontal. Entonces, es super easy. Identification, who is A, who is B. A is the bigger, and B is the smaller. And see, the bigger is associated with the Y. My ellipse look like that. See, the bigger is associated with the X. My ellipse look like that. And you can see, for example, okay, one particular example of the ellipse is a circle. Circle is also ellipse, but in this case, A and B is the same. Okay, suppose, I don't know, suppose in college algebra, nobody talk about of the ellipse. However, the professor talk about only the circle, suppose like that. And you can write, if you multiply the entire equation by 9, you see, wow, the center is again 0,0, but the radius, we talk about radius. Radius is 3, it's square root 9. In this case, A and B is the same. So our ellipse, so circle is a particular case of the ellipse in which the A and B is the same. So the same parameter. We have no major axis, we have no minor. No. Okay, one more thing theoretical about the ellipse. Everyone follow me, guys? I try to explain in a super slow down way and super easy way. Because I want to complicate more your life. I want. But no now. Okay. Everyone follow, yes or no?
Yes,
Answer.
sir.
Eso,
Of
bueno.
course,
So far it's okay, no? So far so good.
We're good.
Yes, sir.
Okay, we have one more important parameter of the lexic, is C. Wow, we have ABC, ABC. What is C? Let me explain the C. Suppose again we come back to the horizontal ellipse. Well, I suppose that this segment is equal to this segment, right? By the way, it's A, and this is B, and this is B. Well, okay. Now C is the focal distance. Focal distance. And this is classical in conic section. Any conic section have foci or focus, no? That depends if it's singular or it's plural. We have two foci and one focus. And the ellipse specific, today we're talking about ellipse, we have two. And the focus always is inside the ellipse. Whenever we have focus outside. No, this is impossible. Okay? And the distance from the center, this is the center, no? The distance for the center to the focus is C, que es the focal distance. Entonces, ¿cuál es la matemática relationship between A, B, C? Bueno, es obvio que A es the big guy. A square is equal to B square plus C square. Okay, look like Pythagoras, but it's not Pythagoras. It's a specific relationship between the parameter of the ellipse, A, B, C. Be careful, guys, because look like easy now. But I want to complicate more. So when you see another conic section, historically called ABC, but it's different concept. That the A and the ellipse is the semi-major axis. The B is the semi-minor axis. And C is the focal distance. And the relationship between A, B, and C is this. We have more interpretation. We have more interpretations. C is the focal distance. Entonces yo soy bueno, profesor. Bueno, what is the reason I need to know focal distance? Well, what is important? Well, it's important. It's important point because I want to prove now. I want to prove, for example, any point, so the definition for the ellipse is the geometric place with the set of the point such that suppose you have focus here, focus 1, focus 2, and this distance is C, and this distance is C, is the focal distance, no? And this distance I want to call D2, and this distance I want to call D1, DD, no B, D1, D1. Always satisfy D1 plus D2 always for any point here, supposing another position, here, supposing another position, is equal to A. And what is 2A? Well, 2A is the entire major axis. This is A and A, 2A. Okay, this is the definition of the ellipse. This is the definition of the ellipse. I want to prove no mathematics, well, mathematics is crazy. I do not apport any information. I create the simulation and Desmos to illustrate very well this idea. I did for not only for ellipse, for any conic section. So one picture and one animation is much better than 1,000 equations. Okay, the student don't understand anything. One more idea, the last one, to start example and see the animation for the ellipse today, is the eccentricity. What the hell is that? Eccentricity. 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 Well, ese parámetro Normally it's called E. And the E, little e, is C over A. The eccentricity is C over A. It's a ratio divided C, is the focal distance. A is the semi-major axis. What is important? The E. Okay. E is important because give me information about how the ellipse look like round or look like flat or look like skinny. Suppose one elixir like that. Ooh. E is approximately 0.95. That means interpretation is the A is the vertex. Is the vertex. Vertex. We have two. And the focus, this is a focus. I'm using another color for the focus. Is very close. Very, very close. And the relationship, and suppose que see eccentricity 1. Boom. This is degenerate to the line like that. It's the ellipse is completely flat. It's completely flat when the eccentricity is 1. However, when the eccentricity is 0, wow. And then this give me idea that my ellipse is completely circle. It's completely round. Okay, entonces actually this is A, this is A, this is B, this is B. But what about C? C is the center is here. And C is 0, the focal distance. In this case, you see now in the animation, very clear. Okay, when eccentricity is a parameter to give me information how rounded or flat or like a flatness is our ellipse. Okay, super. Let me go to Desmos to illustrate. First of all, the definition for the ellipse using the distance. And secondly, okay, sorry. Desmos now. Switching to Desmos. Yeah. Do you see Desmos? Suppose ellipse.
Yes, sir.
Eso. Suppose ellipse. This ellipse is horizontal ellipse or vertical ellipse? Horizontal or vertical?
That's a vertical one.
No. Okay, I call this is not vertical. No, it's not horizontal. Okay,
no, sorry. It's side to side. It's longer side to side. I apologize. Vertical.
You don't accept anything. You need to understand. The issue is where is located the major axis? In the x-axis or in the y-axis? Major. In the x or in the y?
In the
major,
x.
Entonces horizontal. Okay? Look at that. The equation for this ellipse specifically was x squared over 25 plus y squared over 9 equal 1. You can see that the big number get 25. Okay, Feli, no problem. Okay.
It was a mix. Sorry, Professor.
It's okay. I understand. Very well. Okay, the major axis is located in the x-axis, no? And what about, tell me please, what is the A value and what is the B value? A value, B value. A square, identification, A square is 25, no? Remember, A is the big number, A, B, C. A is the big and the ellipse.
It would be 5, correct?
A5. And what about B?
3, sir?
Exactly, B es 3. Entonces si B es 3 and A es 5, you compute C using the formula and the answer is 4, no? Because the 25 minus 9 is 16, square root 16 is 4. I want to explain in detail. No, it's not important, the mathematics now. Important is the geometry feature, the geometry interpretation for the problem. So the typical point, in this ellipse, the important point is bang. Okay, 5,0 and negative 5,0 represent the vertex in plural of the ellipse, and 0,3 and 0,-3. The name of this guy is the endpoint of the minor axis. Endpoint. Entonces, si I ask you, what is the distance? What is the major axis? Well, Fi is the distance from the center, que by the way, the center in this case is 0,0 to the any vertex, Fi. Fi in the other direction, what is the distance of the semi-minor axis? 3 vertical, up, down. And what is the focal distance? Focal distance is 4. And the focal distance at the distance, the foci, because it's plural, is 2, always lie on the major axis. Okay? Suppose that you put it here, it's wrong. And the Y, no, in this case, no. Another ellipse, it's vertical ellipse, que es a little bit flat in the y-axis, so maybe yes, right? Okay, let me illustrate one typical point. Do you see the blue point is running?
Yes, sir.
How you generate this point? Using that segment. Look, one segment for the and to say you adding. Look at the distance formula. I apply the distance formula. Okay, using the first distance. This D1 is the small in this moment. It's 1 point something, and D2 is the big one. And here I put the addition plus D1 plus D2. Look at this change continuously because change the position, no? So this stays the same, it's 10. And what comes from this 10? Wow, it's the entire major axis. It's 5 plus 5, it's 10. This distance is the same. This is the formal definition for the ellipse, geometrically speaking. We can do by hand using a heavy algebra. Of course, we can do that. I use in my paper 2 pages to prove this. But no. This is, I never remember this stupid algebra. However, you remember at least this picture, no? And you remember when I was a student, we have no these tools to understand. And the professor explained that we can use in one piece of rod and you fix it both end of the rod on the paper using, I don't know, something, and try to stretch with a pencil the rod, and you create ellipse. When you try to rotate on the table, okay? This is one animation that I created for you. I have another animation. Do you see or no? Do you see the most important idea? This is important.
Yes, sir.
There we do.
Excellent. Now let me show you the eccentricity part. The eccentricity is here. The eccentricity. Okay. In this case, we have look at the. You can do that by yourself if you want. I put in general the equation for the ellipse here. I put 200 because when you put in the algebra x and y, and your algebra not in decimal, sorry. When you put x and y, your algebra understand very well who is x, who is y. But when you put a and b, your algebra is, whoa, what the hell is that? So you need to define a and b using maybe a slider like that, no? So automatically you put add a slider, and I create a and b, no? And you compute c, que is square root a squared minus b squared. It's the same formula, but the only difference I isolate the c. I call c1 because we have two possibilities of the ellipse, no, vertical and horizontal, no? In this case, no, in this case, vertical, I suppose. How do you know it's vertical? Because this distance is bigger than this distance. And also, you see the focal distance, que es no approach to the vertex, pero es ok. Entonces, suppose que hay increasing A. Entonces, you see que es a little bit more flat, our ellipse, and the focal approaches to the vertex. And look at what happened to the eccentricity. The eccentricity is 0.86. Let me try to increase it a little bit. In this case, I click here. Yeah, I put nothing. I put 20, maybe. 20. So I increase it more. Look at the effect. It's more, well, stretching, no, but you see que the focal approaches to the vertex, and the eccentricity is close to 1. Okay, entonces eccentricity give me one information, how flat and how rounded. Let's move in other direction. Suppose BFI, A is 20. Suppose que A is also 5. Approach to 5. Look at the effect, guy. Look at the effect. Okay, let me make a zoom to see more clear the effect. Suppose now que A is 5. Look at what happened suddenly with the fuzzy. Oh, when it's 5, the focal distance is 0, and the focus is located in the center of the hypothetic no, real circle, because A and B is the same. O sea, conclusion. In the circle, if we study in college algebra, we have no A and B. Why no? Because A is equal to B, if we call R is a radius. And the eccentricity, in this case, nobody talk about eccentricity because it's totally rounded. And the eccentricity, now we're extending more the knowledge, eccentricity is 0. Look at that. Eccentricity is 0 when it's rounded. Entonces now, bueno, curiosity. Let's move on. For example, I suppose que now, wait. Suppose que B is no I increase it to 5. And what do you suppose que the effect? Look at that now. When the B is bigger, que B is the variable, not necessary. So normally in a piece of paper, you suppose always A is the bigger and B is the smaller. But in the software here, I can create in different order, no? But in this case, basically, B is the big number, que is 6.9. And it's associated with the Y. That means que our ellipse is vertical ellipse. Okay? So the most important is, this is the semi-major axis, semi-minor axis, focal distance, and the focus, que is the green point, lie always on the major axis, never in the minor axis. Do you see? Super?
Super.
Yes, sir.
Okay. Let me try to go to the whiteboard and explore our first example. Okay, erase everything. Clear canvas. Okay. Switching to the whiteboard. Okay, super. Switch. Do you see whiteboard, right? Just doing, so as always we are doing by hand, and also we are doing by decimals and verification, and little by little you understand. Example 1. Example 1 is x squared over 16 plus y squared over 9 equal 1. Oh, and you identification in 1 second, que this is ellipse. Why 1 second? Because it's expressed in the classical standard form. And you identification also A squared is 16, therefore A is 4, square root 16, no? And B squared is 9, and B is 3. Now you take like A, the big one. And C, the formula is A squared, the mnemonic device, to remember the formula is, bueno, A, B, C, no? Another mnemonic device is que you remember que A is the bigger, okay? And B and C, no. Entonces, si you want to find C, it's A squared minus B squared. Actually, C is square root A squared minus B squared, and you take only the positive square root because it's the distant. The C is equal to square root 16 minus 9, que es 7. Square root 7, when you have irrational number, you convert to decimal approximation, no? You put in the calculator 2.646. Entonces, the center. The most important characteristic of this example. Center is located in 0,0 because I don't see any translation. No? I see translation when you have here x minus h, y minus k, but we have no this. It's because h and k both are 0. And the center for this ellipse is located at the point 0,0. No? Let's see the vertex now. The vertex is at the distance 4 from the center. Entonces 4,0 to the right and negative 4,0 to the left. Entonces now the endpoint of minor axis can be from the center, but in this case in another direction, in the y-axis, because remember B is associated with the y, is 0,3 and 0, negative. And the foci is located at the point radical 7,0 and negative radical 7,0. If you want substitution radical 7 for the decimal approximation, no, it's the same. How do you know that it's like that, exactly like this, and not like that? Because I know that the foci lie in the major axis. Okay, so one, super roughly approximation. Center here, vertex in 4, 1, 2, 3, 4, 1, 2, 3, 4. Endpoint for the minor, 1, 2, 3, 1, 2, 3. Our ellipse look like that. This point is 4,0. This point is minus 4,0. This point is 0,3. This point is 0,3. And the foci, let me change the color, is 2 point something. 2 point, I suppose, here. This point is radical 7,0. And this point is, no. Sorry. It's approximately here, 2 point something here. And here, 2 point something here. Negative radical 7,0. And the eccentricity, so you want to compute the eccentricity is C over A. So C radical 7 over A, que is 4. And you put in the calculator, this is approximately 0.66. And give me some idea how flat or how rounded. Remember, rounded is eccentricity 0. Totally flat, eccentricity 1. Just close to 1. In this case, no. And the middle is 0.5, no? It's a little bit close to flat. Let me see now clear in Desmos. Desmos, I create one folder que is called conic section. Let me switch into Desmos again. Okay, here. Okay, suppose you see now. Okay. And now we have the example one. Example one is Ellipse. See, example one. Boom. Okay, example one is Ellipse. Okay, and what about the typical point? Well, a typical point I discovered, okay, this allows to the student, for example, A is 4, no? B is 3. H and K are 0. And no translation. 0, 0. And what about P? Well, P, I have no idea what is P, because P is for the parabola. So in the Ellipse, we have the only parameter we have is A, B, and C. I define A and B automatically. C is defined by A and B. And I define que es horizontal, no? Horizontal. Bam! And you can see now the important point. Important point, repetition, vertex, minor, endpoint of the minor, and red color, foci, another foci, and the center. End the story. Guy, if you want, I send to you this GeoGebra no, Desmos script, and you can use it to study, no, and to everyone that you want. Okay. Remind me, because I don't remember sometimes. I remember I sent today. Any question? Any question about this first elementary example, kindergarten example? Remember, my first example is always kindergarten example, no?
All good.
Okay.
No, I went on the road.
Okay.
I got off on the Burke Road. Back to exactly when we just sat.
Say again?
Running a big football.
Hold on, I'm not muted.
Everything is okay? Oh no?
Everything is good.
Everything is good. Okay, let's move on to the second. Example 2. Example 2 of the Ellipse is 25 x squared plus 9 y squared equal 225. Wow, what the hell is that? Well, the problem is, when you identify, guess, one clue to identification, guess ellipse, is because x and y both are square, pero no, the majority, and plus in between, plus, es ellipse. Pero es obvio que it's not already expressed in standard. No, because standard is like that, x squared over a squared plus y squared over b squared equal 1. So the right hand side should be 1, must be 1 in standard. So in order to do something, I divide the entire equation by 225, divided by 225, divided by 225. I put in my calculator, 225 divided by 25, 9. And 225 divided by 9 is 25. And in the right hand side one. Wow, and you have now in standard. You see the transformation, guys? Okay, this is the very first kind of transformation. We study another because sometimes it's not too easy. Entonces, you identification. Who is A square and who is B square? Help me. Who help me? Nobody help me? Come on.
B, A is 25, so
it's
x squared over B, y squared over A.
Okay, A square, you realize A square. Okay, A square is the big number. A big number is 25, no?
Okay, so
A is
yeah.
20, A square is 25. Therefore, A alone is 5, is a square root. And B square is 9. Very well, very well, very well, very well. A is 5. Opposite. Because not necessarily you associate A and X. Remember, we have two kinds of the ellipses. Maybe we have this situation. Okay. This equation or this equation. I don't know. Well, how do you know? I know because A, I know is the big one. The big one is 25. A squared 25, A is 5. And the other is 9. Therefore, B is 3. That means, okay, when the big number is associated with the Y, I suppose okay, our ellipse look like that. It's a very cool. Do you understand the difference? Therefore, that point, so this distance is the semi-major Fi. This point is the point 0.5. And this point is 0.5. This is the vertex. Well, one more time, the center, in this example, again, repetition is 0, 0. And the vertex is located at the point 0.5 and 0.5. And the endpoint of minor axis is this and this. And this distance, I know is 3. This point is a point 30. And this point is minus 30. Okay, it's 3,0 and minus 3,0. This is the endpoint of the minors. I need to find C to plot the Fossey. Now remember the formula is C is equal to square root A squared minus B squared. Yeah, when you isolate C, no? Actually the formula is A squared is equal B squared plus C squared. This is one mnemonic device. You remember ABC. So C is equal to square root A squared is 25, no? B squared is 9, is 16, and square root 16 4. So it's good. It's a perfect square number 4. Therefore, the focal distance is 4. C represents the focal distance. And I know also that the Fossey lie in the major axis. Therefore, this 4 is in this direction. In this direction. This is this first Fossey 1 is 0.4. And this Fossey 2 is 0.4. Entonces the Fossey is located at the point 0.4 and 0.4. And the eccentricity is, by definition, C divided by A, no? And CF4, A5, and decimal to get some idea how approach to 1 is point A. Okay, point A, remember 0 is totally rounded, circle. 1 is totally flat. Point A is close to this. Because I suppose my ellipse look like a little bit skinny, right? Pero vertical ellipse. It's clear? It's clear or not clear? Unclear. Okay, let me see. Let me see in Desmos. Guys, this is the interpretation. The formula you forgot. The interpretation never. The formula, suppose you forgot, you go to the book if you need someday. But the interpretation you never forgot. Let me go to Desmos to analyze the example number 2. Look at that. Okay, that was example 1. No, example 1. Now I want to see example 2. Example 2 is something like that. Woof. Look. Oh, look like the vertical, huh? But I discovered in the paper okay, Fi, AFI, look at that, AFI, B is 3 again, basic coincidence. Okay, and this is vertical ellipse. Boom. And look at that important point. Let me summarize. Center 0,0, vertex 0,5, 0,5, endpoint for the minor axis 3,0, negative 3,0, and the foci is located at the point 0,4 and 0,4. Super. We are the best at Miami-Dade College. We have time for one more? Yes, we have time for one more. Okay, we have time for one more example. Let's move on. So you have no question, let's move on to the whiteboard. No problem, this is easy. Because you always pay attention, Giovanni. You're a good student. The student can follow me every day. The rest, I don't know. But you see the result, I don't care. Okay. So you ask my opinion. The class online is good for the good students. The class online is not good for the bad students. That's it. It's my opinion. Nobody is ready to take online. Only the student can pay attention, dedicated student. Okay? The student gets a mess. Face-to-face hard, I suppose, online. Okay? Send email and do not receive answer. But if I do not receive answer, I put a 0 in Blackboard. If you fail this class. Example 3. Example 3. It's different. A little bit, but not too hard. Okay, copy that. This is already expressed en estándar. Es Ellipse. What the thing I recognize que es Ellipse? Bueno, x squared, y squared. Look at that. I don't care si h, in this case, h and k. We have translation. So the center is no 0, 0, it's another point. I don't know. Es Ellipse. And important, right hand side 1. It's standard. You don't need to divide. No. Okay, super. Now, immediately you recognize who is a square and who is b square. Who is a square? Come on. Okay, 4 and 5. A 4. No. I don't like this, Christian. Remember, okay.
A is 5.
A5, because you take the bigger. The idea is, this is classical mistake of the student, no, but of the beginner, no? I suppose, and the link say always A is bigger than B. So it's obvious que A square you associate with the big number que es 25. Therefore, A5 and B square is 16. Therefore, B alone is 4. Okay? But when this situation happens, when the big number is associated with the y, I suppose, using my common sense and my imagination, que my ellipse es vertical, ¿no? Bueno, okay. Let me erase this. Okay, wait. Entonces, let me finish ABC. Entonces, C es square root A square minus B square. C is equal 25 minus 16. Es 9, ¿no? Entonces es 3. Oh, es 3. Also, the center ellipse is located at the point 3, negative 2. Do you see or no? Okay, look, you compare with this equation. X minus h squared plus, in this case, b squared, because b squared is 16, no? Because it's smaller. A squared 25, and this is y minus k squared. It's obvious that h is 3, but k is negative 2, opposite sign. This is not new for you, right? Remember college algebra when you study the circle, no, que es the opposite sign. What is the reason que es opposite sign? Because in my formula, in my standard general formula, I suppose always minus. But when you say one specific example, plus, it's because we have double minus. So the minus of the formula and the minus of the value. Those are the shortcut to do fast in 1 second, opposite sign. And the point is opposite to the equation. Negative 3, positive 3 in the point. Positive 2 in the equation, negative 2 in the point. Clear? Okay, entonces I plot. Suppose I have no decimal. I try to do by hand. Well, roughly scale by hand. I plot 3, 1, 2, 3, and negative 2. 1. And this point is located my ellipse, my center of the ellipse. But the A is on the Y, no? 5 units. 5 units. Entonces I suppose que my major axis is located parallel to the Y, no? It's vertical ellipse. Entonces 5. C5 is 1, 2, 3, 4, and 5 here. I suppose que es 3, no? Let me check it. Let me check it. I need to understand. It's 1, 2, and 3. In total, is 1, 2, 3, 4, and 5. Because my semi-major is in 5. This point is one vertex. Vertex 1 is 3,3. Vertex 2, I suppose que 5 down. O sea, es 1, 2, 3, 4, and 5. Es negative 7, no? This point is vertex 2 is 3 again, pero coma negative 7. Okay, entonces vertex, let me copy here in the piece of paper, but this is 3,3 and 3, negative 7. Okay. What about the endpoint of the minor? Remember, A is F4, no? F4. Entonces, from this point, I move 4 to the right and to the left. To the right and to the left. Entonces, es 4. Entonces, 4, no 5. 5 is in the vertical direction, 4 in the horizontal because B is 4. Entonces, 1, 2, 3, 4 is 7. This point is 7, negative 2. And 4 in the other direction, okay, I suppose que here negative 1, because 1, 2, 3, and 4 here is negative 1, negative 2, no? Okay, let me try to do at least the idea for the ellipse. It's not good. We need to use in decimals. Not good. Look like a bad 8. Wow, not good. Bueno, okay, let me finish. And what about the foci? The foci is located in this axis. What distance? 3. Distance 3. And distance 3 is 1, 2, 3 here. Okay, suppose that this point is 3,1 is the foci number 1 or number 2, whatever you want to call. And 3 down. 1, 2, 3 here. Is the foci 2. It should be 3, negative 5, no? Because it's negative 2 plus 3, negative. That's it. It's obvious, guys. It's obvious. Well, it's obvious that our ellipse is vertical. It's like that, no? Because this distance is 5, but this distance is 4. And there are no the eccentricity to have idea how to look like the rounded of this is 3/5 because it's C divided by A. And this in decimal is 0.6. Okay, remember 0 totally circle, 1 is completely flat, 0.5 is the intermediate, entonces a little bit here, 0.6 I suppose que es vertical, entonces like that in this category. Let me see clear and decimals. Uy, time is over, no? Okay, so we continue. It's important. Continue this example, complete again in the next day. Okay, remember when it's due the test. The test is due November 24, no? At midnight. Don't forget to submit.
Yes,
No,
sir.
any question that you have about the homework, I can help. I am for you tutor 24 hours per day, 7 days. Okay, Monday, Sunday, I don't care. Okay, the question about the homework, the test. No, I cannot help the test. Okay, but it's similar. Okay. When I create the test, I create first the homework. The example of the homework, I make a selection, I put in the pretest. And after I copy pretest for the test, okay, I change the number. So that you take the pretest, que es infinity time, you are ready to do this because it's the same stupid thing? Okay, guys. See you. Bye.
Thank you, sir.
Pleasure as always.
Thank you, Professor. Have a great day, sir.
You too.